Welcome in sphere part 2, 3D geometry sphere part 2. Here we have selected 3 questions based on sphere. In part 1 we have already discussed if there is a circle and suppose A be the position vector of the center of the circle and R be the position vector of any general point on the sphere and its radius is suppose R, then its vector equation can be written as R minus A mod equal to capital R is the vector equation of the sphere, where A is the position vector of its center, R is the position vector of any general point on the sphere. If center is at the origin, if this is origin, then this equation can be written as simply this is the vector equation of the sphere whose center is at origin and R is any general point on the sphere. Now in order to write it in Cartesian form, if center is taken, suppose x1 y1 z1 is the center and any general point is taken as x, y, z and capital R be the radius, then its radius, this distance can be written as x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square equal to R square is the equation of the circle in Cartesian form, where x1 y1 z1 is the center of the circle and R is the radius of the circle. If center is at the origin, then x1 y1 z1 becomes 0 and it will be x square plus y square plus z square equal to R square is the equation of the circle. Is called standard equation of the circle, x square plus y square plus z square equal to R square. And we have also read an equation of this type, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. This type of equation always represents a circle. This represents a circle in this way. Its center is minus u minus v minus w and its radius is given by root under u square plus v square plus w square minus d. We have discussed all these things in our previous video, part 1. If it is called general equation of sphere, center of the sphere is given by minus coefficient of x by 2 minus coefficient of y by 2 minus coefficient of z by 2, and this radius can be taken as root under minus coefficient of x by 2 square plus minus coefficient of y by 2 square plus minus coefficient of z by 2 square minus the constant term square root is the radius of the circle. So these things already discussed in part 1. Now come to this part 2. These 3 good questions have been collected for you. So let us solve one by one these questions now. These were the results we have already discussed. So before solving part 2, you must go through part 1. These things discussed in detail there. Now come to this question. Try to understand the question. A plane x by a plus y by p plus z by c equal to 1. You know x by a plus y by b plus z by c equal to 1 is a plane which cuts coordinate axis. This is origin, which cuts coordinate axis at a distance small a, small b and small c. In plane chapter we have read this represents a plane whose intercept on the coordinate axis are A, B, C respectively. Given this plane meets the coordinate axis at A, this point is B and this point is C respectively. Question is, find the equation of the sphere through the origin A, B, C. Origin A, B and C through these 4 points. Through these 4 points a circle can be drawn. We have to find equation of that circle which passes through O, A, B and C also. Coordinate of A is obviously A 0 0. Coordinate of B is 0 B 0 and coordinate of C is 0 0 C and coordinate of O is it is well known 0 0 0. Okay. Let the equation of the sphere. Let the equation of the sphere in general form, let us take x square plus y square plus 2gx plus 2fy. It is coming equation of circle. Let the equation of the circle sphere is this one, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Let us suppose is the equation of the sphere. Our sphere whose equation is required passes through the point O, A, B, C. For that, what will be the value of this U, V, W, D? That we have to calculate. This is the general equation. But our sphere passes through the origin A 0 0, 0 B 0 and 0 0 C. For that, what will be the value of this U, V, W and D? That we have to calculate. Then by substituting here in equation 1, we can get the equation of the sphere. Let it be equation number 1. Now this sphere should pass through O, A, B as well as C. If this sphere pass through O means origin, means 0 0 0, 0 0 0 will satisfy this equation. And if 0 0 0 satisfy this equation, means in place of x, in place of y, in place of z, we write 0. So 0 0 0, this is also 0 0 0. What will happen? Only D will left. Start it. Again this sphere must passes through A 0 0. Means A 0 0 will also satisfy it. Means in place of x we write A, in place of y B, in place of z C. Then what will be? In place of x A square. This is 0 0. This is 2u in place of x A, y 0 z 0. D is also 0. From here we write D equal to 0. So this will come. Take it equation number 3. Similarly 0 B 0 will satisfy this equation. Means in place of x 0, in place of y B, this is 0 0, in place of y we write B. So 2VB equal to 0. Equation number 4. D is already 0. This will also satisfy. From there we get C square plus 2WC equal to 0. Equation number 5. From these 3 equations, see, one A can be common and cancel. So what will come? U. If you take one A common and cancel, you will get A plus 2U equal to 0. So you will get U equal to minus A by 2. Is not it? A plus 2U equal to 0. 2u equal to minus a, u equal to minus a by 2. This will, from here you can calculate v, this will come minus b by 2, and from here w will come minus c by 2. From these three equations u, v, w can be calculated. So we have got now u, v, w as well as d. Let us substitute these value in equation 1 to get the required equation of the sphere which passes through O, A, B and C. Therefore, required equation of the sphere is x square plus y square plus z square. In place of u we write minus a by 2. So 2 will cancel, minus ax. In place of v we write minus b by 2. So this becomes minus by. Similarly minus cz equal to 0 is the equation of this circle, is the required equation of the circle. You should remember this as a result. If a sphere passes through 4 points O, A, B, C, or you can say if a circle intersect all the three coordinate axes at a distance small a, small b, small c, then equation of the sphere passes through O, A, B, C is given by x square plus y square plus z square minus ax minus by minus cz equal to 0. Or if equation of a sphere is written in this form, you should understand is a sphere passes through origin, d is not there means passes through origin is the symbol, and its intercept on the coordinate axis are a, b and c respectively. So in this way you can do it. Now come to next question. I think people have written, or video is there, again and again you can watch. Again and again watch, understand and write in your copy yourself. That will be the best strategy. Now come to this question. Second question is the center and radius of the circular section of the sphere. Oh sorry, right here find, not the. It should be find. Find the center and radius of the circular section of the sphere. This is a sphere. It is of the type r minus a mod equal to t. Cut by the plane this. This is equation of a plane of the type r dot n equal to d. You have read coordinate geometry plane chapter. It is of the type r dot n equal to d. One sphere is there whose equation is given this r. It is of the type r minus a equal to r vector r minus a mod equal to capital R. So its center is this. This shows its center is j plus 2k. It means position vector of its center is j plus 2k and its radius is 4. As a sphere given. Cut by the plane this. This is a plane. By this plane, this sphere is cut. in this way. There is a plane, and equation of this plane is given r dot I plus 2j plus 2k equal to 15. This is the equation of the plane. This plane cut the sphere. Then what will happen? Just a minute. Let us write the center here. J plus 2k. This plane cut the sphere. Then you will get a circular section in this way. If a plane cut a sphere, then a circular section will come. Question is, find the center and radius of this circular section. इस circular section का center और radius निकालना है. Equation of the sphere is this, and equation of the plane which cut the sphere is this. Okay. Now see, this is the center of the sphere. From this center, if you draw a perpendicular on the circular section, then this foot of the perpendicular, suppose M, will be the center of the circular section, because it is symmetrical figure. If from the center you will draw a perpendicular, it will be the diameter of the sphere. So M will be the center of the circular section. That we have to calculate the coordinate of M. And what will be its radius? This radius. This is radius of the sphere. Radius of the sphere is 4. Can you find this? The center is suppose C. Can you find CM? CM is length of perpendicular drawn from center of the sphere to the plane. This. Write the length of perpendicular drawn from the center to this plane. Length of perpendicular will be, in place of r, we write j plus 2k. These things discussed in plane chapter in detail. So you must go through plane before reading this sphere. Plus 2k. Just 15 will come this side, divided by mod this n. We know length of perpendicular from a point A on the plane r dot n equal to d is given by a dot n minus d by mod n. This magnitude will gives you length of perpendicular from center on this plane. You must go through these results. What will be this dot product? X is not there, so 0, 1 into 2, 2, 2 into 2, 4 minus 15 by, it is root 9. Its magnitude is root 9. Its mode. So it is 6. So 6 minus 15 minus 9. Minus 9, its magnitude 9. 9 by 3 means 3. 3 is the length of perpendicular from the center of the sphere on this plane. So can you find its radius? This radius, let it be P. Therefore, radius of the circular section will be root under 4 square minus 3 square. So what will come? Root 7. Root 7 will be its radius of the circular section. Now you have to find center of this circular section. This is important. How center will come? Equation of this plane which cut the sphere is given as this. It is of the type r dot n equal to d. So n is the vector perpendicular to the plane. Means n is the vector perpendicular on this circular section also. Means this vector is along this line. This is the perpendicular line. on the circular section or on the plane as well. So this is the vector along this line, and this line passes through this point C. So can we write equation of this CM? Equation of line CM. We know if a line passes through a given point whose position vector A and is parallel to a vector B, then its equation can be written as R equal to A plus lambda B. We have read in these things in detail in 3D geometry straight line chapter. This line CM passes through this point and parallel to this vector, because this vector is along this line CM. So equation of this line CM can be written as R equal to A means this one, this point A, plus lambda B means this vector I plus 2j plus 2k. This will be equation of the line CM. This can also be written as lambda I 1 plus 2 lambda j 2 plus 2 lambda k. And we know this not only the equation of this line CM, it also indicate any general point of the line CM, and this point may be foot of the perpendicular. This indicates any general point on this line. If this general point indicates M, means foot of the perpendicular, then what will be the value of lambda? That you have to calculate. Then by substituting the value of lambda here, we can get R. R means that will be the position vector of point P. So let this is the position vector of M, means foot of the perpendicular. Then what will happen? This will satisfy equation of this plane, because if it is position vector of M, then it must lie on the plane. So this will satisfy equation of this plane, and from there we find the value of lambda. Take it equation number 1. Now if this satisfy this plane, in place of R we can write this, means this dot this is a vector, this dot this equal to 50. From there we will try to find the value of lambda. So this dot this, what will be? Lambda into 1 plus 1 plus 2 lambda into 2 plus 2 plus 2 lambda into 2 equal to 15. From here, after solving, you will find the value of lambda. What will come? Value of lambda? I think 1. You will solve this equation and get the value of lambda. You will find lambda equal to 1. Easily you can find lambda. Now if you substitute lambda equal to 1 here, this will becomes position vector of M. Therefore position vector of M is, here write lambda equal to 1, I plus 3j plus 4k is the position vector of this point. If position vector of this point is this, then this point is obviously it is 1, 3, 4. Position vector of M is this 1i plus 3j plus 4k. So 1, 3, 4 is this point, or in vector form this position vector of M. In this way we can find radius and well as center of the circular section made by the plane on the given sphere. Note down it, then we solve this one. It is same question, but it was given in vector form, it is given in Cartesian form. So let us see this now. Start solving this. So let me rough this part. Written. Come to this question. Find the center and radius of the circular section of the sphere. There is a sphere whose equation is given this. It is cut by a plane, and equation of this plane is given x plus 2y plus 2z plus 7 equal to 0. Question is, find the center and radius of this circular section. Its center and radius is required. I think question is clear to you. Equation of the sphere is given this. What will be its center? As we know, center minus coefficient of x by 2 minus coefficient of y by 2 means minus 1 minus plus 1 minus coefficient of z by 2 minus 4 by 2 minus 2 minus. This will be the center of the sphere. Say properly. Center of the sphere. And what will be its radius? Root under minus 1 square plus 1 square plus 2 square minus this constant term. Constant term here is minus 19 minus plus 19. So it is 25. So 5 is the center of the sphere. So this is 5, and what will be this? Find length of perpendicular from this point on this plane. This point is suppose O, this is suppose M, this is suppose P. What will be OM? OM is the length of perpendicular from this point on this plane. Length of perpendicular can be calculated in place of x minus 1 plus in place of y 1 plus in place of z 2 plus 7 by root under 1 square plus 2 square plus 2 square. In this way we find 4 plus 7 11, 11 minus 1 10, 10 plus 2 12, 12 by 3 it is, means 4. So this radius is this length of perpendicular is 4. So what will be this? 25 minus 16 9 3. So this radius will come 3. Now the main thing is how to find center of this circular disc. Okay, can we write equation of this line? This line, this is a line passes through this point and perpendicular on this plane. This is the plane x plus 2y plus 2z plus 7 equal to 0. So 1, 2, 2 are the direction ratios of the normal to the plane. We know this. If equation of a plane is written in this way, then coefficient of x, y, z are the direction ratios of the normal to this plane. And this line OM is also normal to the plane. So equation of this normal line means OM can be written as x minus x1. These are x1, y1, z1. X minus x1 by this 1 equal to y minus y1 by 2 equal to z minus z1. Z1 means 2 by 2. In this way we can write equation of the line PM. This is equation of line PM. You can write it this side lambda, and from here any general point on the line can be written as minus 1 plus lambda 1 plus 2 lambda, 2 plus 2 lambda. In this way we can write any general point on this line. From here find x, y, z. This will gives you any general point on this line. That general point may be M also, but that general point will be M only when that general point satisfy this plane, because M is a point on the plane. From there we find the value of lambda, and then by substituting the value of lambda here only we can get the point M. So let us suppose this general point of the line is the foot of perpendicular, means M, and hence this will satisfy this plane. So what will happen? In place of x we write minus 1 plus lambda, plus 2y. In place of y we write this, plus 2z. In place of z 2 plus 2 lambda, plus 7 equal to 0. From here we find the value of lambda. You will simplify it and get the value of lambda. How much coming?
Minus 13 by 9.
This value of lambda is coming minus 13 by 9. This is coming value of lambda. Now if you substitute this value of lambda here, you will get this point M. Therefore coordinate of M, what will be coordinate of M? Minus 1 plus lambda. Lambda means minus 13 by 9. Y coordinate will be 1 plus 2 lambda. Lambda is minus 13, so 26 by 9. Then Z coordinate will be 2 plus 2 lambda. It is minus, so this become minus, so 26 by 9. Both will come same. No, it is 1 minus 26 by 9, it is 2 minus 26 by 9. This will gives you coordinate of point M. So in this way you can find radius of the circular section as well as center of the circular section. So properly go through these problems, solve yourself and get the answer. This is part 2. In part 3 also we discuss some more result related to a sphere and problems also. So go on watching a sphere part 3, part 4 also. In this part, these 3 questions only. Thank you.